Hello friends, this is the first time we are doing live on YouTube. It will be very short cause we are doing for the first time. Give me feedback in comment how it is. Thank you. So the question is, you have to justify these sentences. Citric acid is important for fatty acid synthesis and HMP shunt is useful for lipogenesis. Now for fatty acid synthesis or lipogenesis, we need three things. First one is multi-enzyme complex, that is fatty acid synthase enzyme. Fatty acid synthase enzyme. Second is acetyl coenzyme A. Acetyl coenzyme A. And third thing we need is NADPH. These three things we require for fatty acid synthesis. Acetyl coenzyme A is formed in mitochondria. By three ways. Number one is by link reaction, where pyruvate is converted to acetyl coenzyme A by pyruvate dehydrogenase enzyme, where decarboxylation or you can say oxidation of pyruvate occurs and formation of acetyl coenzyme A in mitochondria. The second way formation of acetyl coenzyme A is beta oxidation of fatty acid. And third and the least important is amino acid metabolism. However, this acetyl coenzyme A is in mitochondria. It is in mitochondria. And fatty acid synthesis occurs in cytoplasm. So this acetyl coenzyme A has to be transported to cytoplasm. So here comes the role of citric acid. Citric acid helps in transportation of acetyl coenzyme A from mitochondria to cytoplasm, as acetyl coenzyme A is being impermeable to mitochondrial membrane. Oxaloacetate and acetyl coenzyme A forms citrate. Now this citrate is permeable to mitochondrial membrane. It will be transported from mitochondria to cytoplasm. In cytoplasm, it will be acted upon by ATP citrate lyase and again form oxaloacetate and acetyl coenzyme A. Now this acetyl coenzyme A can be used for fatty acid synthesis. So now you can understand that why citric acid is important for fatty acid synthesis. Apart from acetyl coenzyme A, we need NADPH also. We need NADPH also for the fatty acid synthesis. Now sources of NADPH are, first is HMP Shunt Pathway, HMP Shunt Pathway, which occurs mainly in liver, adipose tissue, lactating mammary glands, where exactly fatty acid synthesis also occurs. About 50 to 60% of NADPH is provided by this HMP shunt pathway. Second source of NADPH is malic enzyme, where malate is converted to pyruvate and formation of NADPH. And the third source of NADPH is cytoplasmic isocitrate dehydrogenase reaction, where isocitrate is converted to alpha ketoglutarate and there is a production of NADPH. Mind well, it's a cytoplasmic enzyme, cytoplasmic isocitrate dehydrogenase. In mitochondrial isocitrate dehydrogenase reaction, which is a TCA cycle reaction, uses NAD as coenzyme. Here in cytoplasm, it uses NADP as coenzyme. So the major chunk of NADPH is provided by HMP shunt pathway, as we have discussed earlier. So now you can understand this second line, HMP shunt is useful for lipogenesis. Next important question is, G6PD glucose 6-phosphate dehydrogenase deficiency leads to hemolytic anemia. Now this is also related to HMP shunt pathway. The first step of this pathway, where glucose 6-phosphate is converted to 6-phosphogluconolactone by glucose 6-phosphate dehydrogenase enzyme and formation of NADPH. If glucose 6-phosphate dehydrogenase enzyme is deficient, then there is no formation of NADPH. So what will happen? This NADPH is required for conversion of oxidized glutathione to reduced form of glutathione, which is essential for detoxification of hydrogen peroxide. If H2O2 is not detoxified, result in accumulation of peroxides and methemoglobin in RBCs, leading to cell lysis. Actually it is hemolysis. So it will lead to hemolytic jaundice and hemolytic anemia. So now you can understand this sentence, G6PD deficiency leads to hemolytic anemia. So this is all about today's live session. It is ultra short. Hope you like this. We will do more and more live session in upcoming days. Thanks for watching.